This is Anthony, and I'm going to be running through problem set 2-4, finding the lowest monthly payment using a recursive bisection method. So I'll start this one off by creating a new function, and it's going to take the upper bound, the lower bound, an initial balance, and a rate. Low balance and the interest rate. And the first thing we do, like a binary search, we'll just initiate the midpoint, which will be directly in between high and low. Midpoint is going to be equal to high plus low divided by 2, essentially taking the average, which finds the middle. And then we will set the balance that we work with to the initial balance. And then from here, we are ready to iterate through and find the best value. So we'll go through the range of 12 months, which is when we're trying to pay it off. And then we will find at the end of each month the balance. So we'll pay it first, and the paid balance will be equal to the balance minus the midpoint, which is the payment we're working with this time around. And then we will set the balance to be equal to the paid balance plus its interest rate. And then once we iterate through it, we will find our final balance, and then we will see how to proceed from there. So if we're within our acceptable range, we'll try that one first. And I picked a pretty small acceptable range. I wanted to see how close I could get to 0. Never can quite get there though. If it's less than or equal to 0, and it's greater than a very small number, negative 0.000001. If it's in between that very small range, then we will return it as our payment. And we'll just print it out as well. Lowest payment is midpoint. And then we will go through our others if we are not in the right range. So if the balance is greater than 0, meaning we didn't pay enough, then we will call the function again recursively, and we will give it new values. This time the low bound will be our midpoint, so that we would pay more this time around. So we'll give it to high, and now instead of the original low point, we will give it the midpoint. Then we will give it the initial balance and the rate to do it all over again. On the other hand, if we pay too much, for this case, negative 0.000001, If the balance is less than that, we want to get closer to 0. So we will call the function again, this time replacing the original high bound with the midpoint, so that we would pay less. Set our original lower bound, your initial balance, and the rate. And by the end of that, we should have found our payment. Now we'll create an entry for it. And this one, we'll just take the balance. And then inside of it, we will declare a rate and the high and low bounds. The rate will be, in this case, 18%, accounted for monthly over a year, divided by 12. The low bound is going to be equal to our balance divided by 12. And the high bound is going to be balance times 1 plus the rate times 12, all divided by 12. And from there, we can call it with $5,000. See what we get. We never called the function that actually does something. High low. So at our entry point, we'll call a function with the high low, the balance, and the rate. That should do it. Run it, and lowest payment for $5,000 is $451 and about 63 cents per month.